Hello friends, welcome to my channel. Today we'll discuss about various fundamental concepts, for example constant, variable, if-else condition, loops, while loop, for loop, etc. This would be mostly example oriented video session. Now let's get started. So using static keyword we can define a variable. So there is a similarity between a static keyword and a constant keyword. In both the cases, we have to mention the type explicitly. A type cannot be inferred. The language would be treated as a global variable and the memory allocated, and language is not specific to scope. The lifetime of it will be only destroyed when the program execution stop. Whereas constant is tightly with the scope. The memory will be allocated and can be deallocated. For static, you can't explicitly use a drop keyword and deallocate the memory. Using the constant, once you initialize and allocate, there is no mute keyword associated with the constant. You cannot change the value once you declare and initialize with a const keyword. But whereas static, there is a mute keyword is associated with the static, but it is not recommended to change value when you define a static variable. But using onSafe functionality, you can able to edit the content using static keyword, but we'll see in a few minutes. So inside the main program we can access and it is printed. So the value is printed here. If you try to change the max counts to some other value, so it will throw error. So whenever you don't want to change any data, so you use the constant keyword. Similarly, you cannot change the language also. But using the mute keyword, we can able to change it. But if you notice here, still it is complaining, there is some errors. So use of mutable static. Mutable static can be mutated by multiple threads. For that reason, we have to use it. This operation is unsafe. So using unsafe keyword, if you try to update the value of static mute, you can change it, and this language will update it to French. But this is not very commonly used. So it just for your information, I provided this example. And this is the normal way how we can define a variable. This is known as immutable variable. And if you see the type, we don't need to mention explicitly. This is auto inferred depending upon the value what we have provided. If you try to change the value variable, so it won't it won't allow you to update variable, because this is a little bit different than constant. Constant, you have to initially, you can't variable you can declare without having any initialized value. But in constant, in the same line, you have to declare as well as initialize, and this is known as immutable variable. To make it mutable variable, you have to use mute keyword. Then you can change the value of that age. So we have assigned 30 and we have incremented to 1. So if you see in the right hand side, age would be 31. Whenever you are going through Rust program, so you'll see most of the time many developer use this underscore word. So this underscore before the variable stands for unused variable. If you are not sure about using wherever you want, if you declare it and don't use it, it will throw some warnings. Because I am suppress the warning, so you can't see that. But if I get rid of this line, so you'll see some warnings related to age and other thing. But if you notice here, there is this, because of underscore, there is no warning. But if you remove here, this underscore, it is complaining unused variable. So this underscore will suppress this warning. And I don't want to see other warnings as well. So for that reason, I am using for my demonstration purpose this particular line. And this is not recommended and it is a bad practice. So I suggest not to use this line when you are doing your coding. Now using curly bracket also, if you want, you can use, you can write your own code. So the scope of this variable y you can only access inside this curly bracket. Outside of this, the memory will be freed or deallocated. But inside this curly bracket, you can use x, but outside of this curly bracket, you cannot use y. So this is very well inside this, I is trying to print x plus y. So x is 5, y is 10, so it will lead to 15. So you can declare and initialize the variable x again. It is perfectly valid syntax. This is known as variable shadowing. So if you see here, you cannot access y here, cannot find y in this scope. Here one interesting bit. So here we have did the variable shadowing. At this moment x is 5. Here you are trying to use x equal to 56, and when we get printed in this line, so x56 is printed. But once we will come out of the scope, so any changes to this shadowed variable is not going to affect. So x will still remain the 5. So this shadow variable scope is still limited into the scope it defined. Scope means the starting and ending of the parenthesis is more treated as a scope. So this you can do, it is a perfectly valid syntax. So you can declare the variable, but it is still complaining. So even though you declare it is valid syntax, but you have to, immediately initialize the value. Then this error will be gone. Or you have to provide a type for that because the type is not inferred. What I'm trying to say? So if you don't declare, you have to explicitly mention which type it would be there, so that this variable, now this error is gone. So once you declare without any initialization value, so you have to declare the value. Now here it will complain because we have not, we declared it, but we have not initialized some data. So this is a user possible uninitialize z. Now we declare it, initialize and try to print it. So z would be 5. So there is no problem. So we have discussed about static variable, how we can change using unsafe keyword, and constant. Constant in this case we have to specify the type as well as you have to initialize some data. But in the variable, we using the mute keyword we can change. Otherwise it is a immutable variable. and underscore stand for unused variable, and we discuss about the scope. Now proceed to the next topic. Now let us discuss about casting. In most of the cases, Rust doesn't provide direct type coercion or direct conversion from one type to another. It is sometimes difficult, but some type of primitive cases, for example, float to other type, it provides some mechanism for doing type casting or converting from one type to another type. For example, float to int and so on. Here we define salary because we given 40.50, it is auto inferred as a float 64-bit. And whenever we assign for a primitive type, for example, int, character and float, the data itself will be copied because the float itself is stored in a stack memory, not heap. Inside heap, it is a kind of reference. But in a stack of primitive variables, the data itself copy. So both will contain float data 40.50. So in this case, I have explicitly given the U8. I'm trying to do a typecasting. But by doing this way, it is not happy. It is still complaining that expected U8 and found floating point numbers. So to get rid of this error, we have to use as keyword, as U8. So in this fashion, we can convert the float data to a integer. You can use U8, I32 or any proper integer, floating to integer, you can do that. And in this case, you can convert this U8 to character. This is a valid syntax because character is also represented by U8 internally. If I try to print it, salary is 40.5, sal is 40, it is U8, and that is converted to character as this left parenthesis. But the conversion is not straightforward in most of the cases. So using this salary as character, it seems to be inferred as character. Looks both are valid, but if you save it, it is not a valid syntax. You cannot convert float to character. It is invalid cast. Only U8 can be cast as a character, not F64-bit. So I'm not going to go through all the elaborate rules which you can cast or not. But once you stumble upon, so you have to go through some reference to identify that which of the casting is possible. You don't need to memorize every casting rules. Now we'll discuss about one of the advanced concept of casting. How we can cast from two completely different data type. For example, a struct to a tuple or struct to some other data type. Is it possible or not? So in this kind of Rust, in the previous example also, you can see some from string to some one data type to another. So we'll create our own custom solution how we can convert from one type to another. But in the standard library, this from usage is widespread. So you will see in many examples for when this casting is happened from one type to another. One very common example is that from ampersand star to a string data type. Ampersand star means this string literal is stored in a program memory, or it is available as whenever you created a binary package. So this would be part of your .exe file. But you can't the length in the compile time itself. If it is part of binary, then you can't access the dynamic data. You can't take as input and store as a star. Or you can't take the data from the API because that length is undefined, and you can't do some operation. For example, the string can't grow or shrink. It is fixed in size. But whereas This string is much more popular string data type. This is allocated in heap. This is growable, shrinkable, and this is part of standard library. Okay, if you see the string dot colon colon, this is a module. This is a struct. So colon colon from is the associated function available here inside string. You pass the string literal and you get the string. So this from is responsible for converting the type from star to string. And we can also create our own custom solution or custom implementation of from. This from is, there is a from trait. Trait is kind of interface. If you implement that and provide the signature and the implementation for us, so we can use from wherever we needed it. To demonstrate it, that implementation of from trait, by default, I'll give an example. So I've created a point struct which contains two fields, X and Y. And for convenience, I'm using this debug macro so that I can print it as a debug. So in this syntax, we can create a immutable variable P where point, curly bracket, we provide this initially with some data, X equal to 0, Y equal to 7. And let us debug it. So X and Y is printed. Now we'll try to convert from a tuple to this struct. Because let's assume that we get the data as a tuple, XY value, and we want to convert to this, like for example, start to string. String is a struct. So we have a point structure defined, XY. But once we get a tuple is a collection of different values. We get a tuple syntax, pair of data. That will take as input, and we want to convert to a point struct. So for that purpose, there is a trait. Trait is a kind of interface or abstract concept. It has some certain functionality. Once we implement it, then we can leverage some of the different features of it. So this is the signature. IMPL is for implementation of this. This is the trait name. This is from. So this is part of the core trait. This is not part of a standard trait. This is a trait. So inside this we are using generic syntax and using tuple syntax. Generic with combination of tuple. We are expecting this to deal with two integer values. For point is our custom struct. So we are trying to implement this from trait for our point struct. So all the functionality, so the signature. So this signature is generic. So even the string also under the hood, it is implemented this particular trait and this particular function. So whoever providing this from, so they provide this similar syntax. Because this is generics, the input or arguments may be different for this from to our implementation. But because this is generic syntax, so it allows for greater flexibility. I'll discuss more about this just to give a feel about the fundamental concept, how we can deal with the converting from one to another. But if it is a little bit advanced, then I'll slowly cover one by one and go deeper in the future videos. Also, I created few past videos where I gone very slowly. I highly recommend to watch those videos. So from point is our input argument. It is a tuple i32. It will return self. Self is nothing but point. So instead of self, if you want to write point, that is also fine. So here we are instantiating this point X and Y. So because the tuple, we can access the value as a .0 and .1. And there is no semicolon here. That means that this particular statement will be written as a self. Self is nothing but point. So we will create an instance of it. So whenever we do this point colon from and we pass a tuple, so that would be converted to a particular struct type. So we are converting from tuple type to a struct point type. So we can use any other combination. See, point from. So instead of using the curly bracket and giving xy values, so we can pass like tuple. So this is the same point will be created. See, this p is printed as x3 and 4. And once you implement from, there is another nice method you will get in return. So you don't have to do anything at all. Whenever you implement the pay trait, so let's assume you have pay trait. So instead of using the point colon from, you can use a simpler syntax. Pay.into. So pay.into is by default it is not available. But because you implemented this from trait, so you will get the into as well. Because we are converting this tuple to a point, so this will be automatically recognized. But there may happen that you want to convert this tuple to point and some other different type. So it is a bit difficult for Rust compiler to understand that from into is fine, but which type you want to convert. So it cannot unambiguously decide or infer which type you want to convert at this point. Because there may be possibility that you want to convert to point or rectangle or circle. I'm just giving a superfluous example, but you have to explicitly mention the type here. Otherwise it will complain. So type annotation needed. So once you give explicitly type, so this error will be gone. And we can see the same point here, x and y. Now we'll discuss very simple concept, if-else condition. And let's see that what makes Rust a little bit different than handling this if-else condition. But prior to that, we'll see one more concept. If you try to convert a string to a integer, so you can use parse. This is a string, literal is a parse, and parse will return a result. Result is a kind of enum, because there may be possibility that it will succeed, or if your string is not a number, so it may fail. Because there is no exception inside Rust, so most of the time where you are expecting an error, it will return a result enum type, which contain two values. One is okay, another one is error. And once you do unwrap, so you are getting this data itself, like 34. And in case of error, it will panic and it will crash the program. But it will save it. It will still complain because the type annotation is not needed. So it can't able to infer like which type you are expecting. Whether you are expecting a floating point number or a integer number or which bit it is unable to know. So you have to explicitly mention, because 34 is a smaller number, you can say that I need a U8. There is an alternative syntax for it as well. So same parse, but you can use colon and here you can give type. But this syntax I doesn't like that much. So colon a type and the curly bracket. So between this parse and colon parenthesis, you can have to use the type information here instead of here. It is up to you which syntax you use, but rest things are same. So we have seen this code earlier. X we have defined in the outer scope and Z we define in the inner scope. So here we can use like x plus j. If you use and we can store in some variable as well. So this is a very interesting thing inside Rust. So if you use a scope, here we can do any calculation, and if you know whatever the last line without semicolon, the value would be written and stored in a y. The type would be in 4 depending upon x and z. The x is 5, z is 3. The summation would be written and stored in a y. Y equal 8. The interesting thing to note over here is that if you put a semicolon over here, so it would be void, because semicolon means you are not returning the last line. So you are returning nothing out of the scope. So if you see, this type would be empty or void. Okay. Now we'll see the simple if else condition. We define a variable age. If age is greater than or equal to 21, we print some information, else we'll print some other information. We can use else if also. One important distinction is that we don't need to use the parentheses to, you know, around this age, around this condition. Rest, it is the same as JavaScript, Java, C or C++. It is a similar syntax. So our age is greater than this, you can buy a drink, is printed. And one very important concept is that, similar to the scope, inside if else condition, this can be used as expression only. Expression means something which returns some data. So inside this condition, we can use equal to symbol. This is not very common across other programming languages. So inside, if there is a condition, you can return some data, because I am not using semicolon over here. So the data will be written and stored in the each of variable. But here the semicolon is needed. So it is sometimes a bit confusing. Here is this standalone if else condition, there is no semicolon here. But if it, because this is expression, because this let keyword is required a semicolon here. If you don't keep, it will throw error. But actually this is each of age will contain the data is true. So inside this if else condition also, you can return some value or variable, and that you can assign into some other variable, and you can access later point of time. Now we'll discuss about loops. There are three common type of loops. One is infinite loop or loop syntax, which is a bit new or different than inside Rust. Second one is while loop, and third one is for loop. And we define a counter variable. Inside loop, we have to just increment some value so that we can see some information like how this loop is working. And I will be making it mutable variable because I want to change the data of it. So this loop keyword we can use, and this is a bit different syntax than other programming language. You may not find, I never find in another different languages. It's kind of infinite loop. If I can save it, this program will be keep on going on that, and the CPU will be, and after some time it will stop. I don't know. Let me save it, do that. What will happen? It is still running, I think. And program will crash. If you debug some information, yeah, see, it is keep on printing. Now put a break. If count equal to 10, then it is break. I should not try to do this infinite loop, but it is also looping infinitely time. Maybe once it is out of memory or some CPU it will consume, then it will crash, but it is still looping it. So if count is equal to, you must have to put some kind of break condition, otherwise your loop will go on. So you print a 1 to 10. We can access count outside of it. So count outside is like, 11. Oh, sorry. Yeah, once it exit, like 10 will be printed twice because this is not incrementing again. So that after break, this count value will be also 10. And once we can continue as well, we can use the break and continue keyword. If you do continue, right, for this particular loop in iteration, this particular other code won't get executed. So if it is 5, this debug statement won't be printed. So if you see the 4 and 5 got skipped and 6 is printed. Because after 5 we just continue it. Means the other code won't execute it, but this loop won't be break. The loop will continue, but other code won't get executed. This is a bit interesting. Even inside loop can be act as an expression, or we can return something from a loop and assign some value. So loop may execute multiple times, but whenever you are breaking that loop, so that particular data, you can do some calculation. Here I am adding 10 plus 50 and I am returning that. So even though I am not explicitly using any return keyword, but this count plus 50 will be returned. If you in conjunction with break, the data will be stored in result, and result will be 60 here. So this is a bit interesting concept. Or you can inside the loop also you can use like label. This is like tick single quote. You can give any label and colon, and then all the loop concept. And you can nest the different loops so that this would be helpful if you do a multiple nested loops, one loop inside another loop. So like that we have outer loop, we have inner loop. Here also you have to remember to break the loop, because if you are breaking this outer loop, this inner loop also will get terminated. So we print once and we come to inner loop, we printed this inner loop syntax, we break. So this code will never get executed. Outer loop, inner loop will be printed, and this the loop will be, both loop will be break. Now let's see this while syntax. While is a simple concept. Like inside, it is not kind of infinite loop. All the breaking condition you already specify as part of this condition in the while loop. So while, when this condition will reach, the loop will be exited. Inside the loop I am incrementing it. So this loop will be exit. If this count equal to 10, this will be break. We are making some explicit break. This count value will be 10. If you don't put a break, then this count will be 20. Because after 20, whenever it is not less than anymore, then this loop will be exited. Finally, most popular loop of all the 3 different loops I use most frequently, that is for loop. So here we can do for in loop. This is known as for in loop. And here we don't need to give the let keyword to declare the variable I. So you can skip this I and you don't have to specify the type as well. The type would be auto enfold. This is the range syntax. This is very commonly used in conjunction with the for loop. So this is not exclusive 11. It is 1 till 10. So 11 won't get printed. So 1 till 10. So if you use equal to, then it is inclusive of 11. So 1 till 11 will be printed. But if you see, this is not same as the index. This is the data. And most of the time you are very comfortable using see the index of an array from 0 till that array length -1. So in that case, this is the range syntax we can use, and we can use a enumerate function. Enumerate will create a iterator. Mostly under the hood, this range and all the array, we have to use iterator. Iterator is a, so one trait is their iterator. So they provide like different functionality. So all the collection are using iterator heavily. So I've created a dedicated video for iterator earlier, or also in future I'll create more videos with some example going through iterator and various gotchas dealing with that. But for the time being, you understand this enumerator will create some iterator, and which will return this tuple I and j, I of u size and j of i32. So I will contain the index and j will contain the value. So I start from 0 to 5 and j start from 5 to 10. So we can define this array syntax. Array, this is like this array is created in stack because it deals with the primitive data, and in compile time only we know the length. So we can use we have to use iter keyword to return the iterator. So using this for in loop we can iterate it, and this is like ampersand i32. This is a reference of this data. So it is I doesn't contain the data itself. It is a pointer to that data what is stored as 5, 10 and 15. So I equal 5, 10 and 15. So we can use like vector keyword. So vector, this is a vector is a, it will allocate the memory in heap, but these are the individual star data we are using. So the vector also we can loop using this names.iter, and here this is the ampersand star. There are two ampersand. So always the name is in this is a reference to the actually star. And there are different kind of iterator like into iterator mute, which will allow us to change the data itself inside a collection. That we'll see in some more dedicated videos. So this video is about mostly dealing with the for loop. Before I wrap up for today's video, I would like to give a big thank you to this Rust by example books, because most of the examples in today's videos is mostly derived from this particular book. This is freely available and this is official documentation. Please have a check. I will give this link in the description below. Thanks for watching. Have a good day ahead. Bye bye.